All right, good afternoon, everybody. Thank you. Thanks for sticking around. My name is Paul Davies. I'm going to talk a little bit about this application we've built. Last year at AWE, I talked about more generically what the BARC is, the Boeing Augmented Reality Kit. And it's a suite of kind of hardware and software and algorithms that we've built that we can kind of use to rapidly build and deploy AR applications, mostly in the factory, but also for other use cases around the company. And this is one we've been building for almost a year now, actually. And so I'm going to it's kind of a deep dive into the use case, and then I've got some videos and the demos of how it looks, and then I'm going to talk a little bit about the data, the back end, and where that comes from. So this is the problem that we set out trying to solve. On many of our platforms, this is a commercial aircraft, a twin-aisle aircraft. The wiring can be so complex that really we're at a point where you really can't convey an effective work instruction or an effective design using paper. These are pictures here of electricians holding these huge paper drawings. They're extremely complex. They're really difficult to relate to the actual aircraft. And they spend all the time trying to understand these drawings. And in fact, even so much as stepping off the airplane, looking for 3D views, asking engineering to produce new views. And different people interpret these drawings in different ways, which is a huge problem. There's been many cases where a first shift will come in and install some wiring, read the drawing, install wire harnesses. QA would come in, quality inspector would come in, would reject it. Second shift would install it. The first QA would interpret it differently, and he would then reject it again. It was like this death cycle of inefficiencies. And so we really wanted to help them understand how to effectively route harnesses in complex confined spaces like this. So the two things we set out to try and do, as I said, we started in June last year. One was to eliminate all time spent by electricians performing any kind of research. Any time they spent trying to understand the job, whether it be on the airplane looking at drawings or stepping off the airplane looking at 3D models or anything, we wanted to eliminate all of that. And secondly, we wanted to increase the number of first pass qualities to prevent this QA rejection cycle that was going on. So those are our two goals going into it. So we did what most people do. We built, there's supposed to be a picture of a HoloLens there on the right-hand side. I don't know why it's not showing up, but you can imagine. We built an application. Can we go back one slide? We just built a Unity application. We baked in some 3D content. We exported it from a CAD system. We baked in some wiring models. We put in some text and some other alignment points and things that we felt that we needed. We manually sideloaded it onto a HoloLens. We took it to the factory and we said, try this and let us know if you think it would be feasible. And that's what this system looks like. So there's somebody wearing it. He's looking up and he's seeing, spatially registered wires along with some tag numbers and continuation drawings and other things that we need to convey. But this was all kind of canned data. It's not live. The effectivity wasn't monitored or anything. We just wanted to kind of get some initial feedback. So we had a few electricians look at this and then provide some basic feedback, and we determined that it was going to be enough for us to pursue. So we quickly decided that we needed to get, as is usually the case, live data onto the device. We can't have like offline content that could potentially be stale, especially if design changes occur or anything like that. So we needed to tie into our engineering system so that we could pull the latest wiring design models onto the device. So that's what we call basically the back end. I'll talk about these parts separately, but the back end is a server that sits next to the airplane. It's just a Windows laptop, and then the front end runs on Unity on a HoloLens, and the two talk to each other over a local Wi-Fi network. So I'll walk you through basically the workflow of how an electrician and a shift lead interact with the system to get those drawings onto the device, and then we'll see a demonstration of what it looks like. So all of our wiring jobs, in fact, all of our jobs now, we're trying to get down to a 2 to 3 hour block of time per job. Another word for job is installation plan that might appear up here. But essentially, an electrician will be assigned 2, 3, 4, maybe 5 installation plans for a shift. And then he would go pull those jobs from the manufacturing execution system. You go get the drawings that the job calls for, and then he would go to the aircraft and do it. This is the new way that we are piloting today. So if I walk you through this, The first step is the shift lead goes to our our back-end server, which is a computer sitting by the airplane, and he creates the content for the job. So basically he types in the job number that his electrician is going to perform. Then our web service goes and gathers data from our engineering systems, and in this case we're touching two engineering systems. One is the manufacturing execution system. We're using CMES for this program. So we go pull out the job from CMES through a web interface. Once we get the CMES job, the job will call out which wire bundles need to be installed as part of that job, and usually it's 2, 3, or maybe 4 bundles. So we'll then go to our modeling system. It's called 3DPI, 3D Production Illustration. We'll pull out the drawings that the job calls for, the latest versions of the drawings. And then we'll package all that up, and we'll build it into a Unity asset bundle along with some other information, some alignment points and things, and then we'll stage it on the server. And that would be number 6 or 7. And then, so it stays on the, when the electrician picks up the HoloLens, he identifies himself to the HoloLens using a QR code, and then the system will download all of that electrician's jobs for the whole day, the whole shift, onto the device, and then he knows he has the latest drawings, the effectivity for that tail number and everything else, so he can go install those wires. I'll walk you through this in a little more detail with some screenshots, but that's kind of a rough high-level overview. So functions of the back end, as I just described, automate the packaging of the content into a Unity asset bundle, and getting the latest engineering drawings. That was the big achievement here. Interfacing with CMES and the drawing system to pull the latest models. We're really pleased that we got there. Delivering the asset bundles to the AR device over the network, and then we also monitor the status of these bundles to make sure that they don't go stale. We don't allow any data to exist anywhere in the system, either on the front end or the back end, to live for more than 24 hours. If you build a job noon on Wednesday and you don't access it for 24 hours, the system will, we have a service that monitors and it'll just delete it, which will cause you to rebuild it. That's to make sure that we don't end up with any old drawings or any old engineering making its way out to the HoloLens in the factory. And then we periodically remove all the old content. So just briefly, I wanted to mention there's really two sides to the back end. There's what we call the on-network piece, which communicates to our enterprise systems. That's the computer that sits in the factory. There's the off-network piece, which is actually another computer, and they are isolated. They're not on the same network. And we actually have to transfer data between the on-network and the off-network, and we do that using actually just a thumb drive today. We do not have the HoloLens connected to our Boeing enterprise network today. That's something we're working on, but at the moment we don't connect the device directly to the network. So we had to kind of create this kind of like segregated architecture where the on-network piece does all the manufacturing systems communication. The off-network piece talks to the HoloLens, and we have to kind of transport the data with a thumb drive. It turns out it's not too big of a deal, and we've kind of architected both of these things to work to work in that mode. So it actually zips everything up and puts it on the thumb drive automatically, and it just instructs the user to pull out and plug it into the other computer. When the off-network server detects it, it just moves it over. So it's not a big deal, although it is something we're trying to fix. We built this system to be very modular. If you look at all those services, I hope you can read it. I mean, one says there's the CMES service up there on the top left. In our case, our programs use different MES systems, different data stores. For the program that we're working with, this is the configuration that we needed. If we wanted to move to a different program, we may have to rewrite some of these services, but we wrote it in a very modular fashion so that we could do that quickly. If another program doesn't use 3DPI, we would have to rewrite that 3DPI module, but we would still use the same overall architecture to do that, to achieve what we're trying to do. And then the off-network computer is the one that has the Wi-Fi router that communicates, transmits the asset bundles to the HoloLens. So I have a few screenshots here of what the system looks like, and this will kind of follow the same flow as what I described on the architecture chart. But this is the main landing page for the backend interface. And so this can be accessed from any computer on the Boeing network, on our enterprise network, because that system is on the network. So 3 things you have to enter to when you're trying to build a wiring job for the electrician is the order ID or the installation plan. That's the job number. This is all done by MEs, manufacturing engineers. So yeah, the lead would enter the job number, the line number, which is the serial number of the aircraft coming down the line, and then the sheet number of the drawing that pertains to the job. And then those are the 3 boxes in yellow. Then on the right-hand side, the lead would select which electrician is going to perform that job. So that kind of links that job with that electrician. At the bottom, you have to select a set of alignment points, and I'll explain what that is. That's basically how we register the drawing to the airplane, and I'll explain how that works. Once you've done all those things, you just hit Make Asset Bundle, and it goes into a queue. We actually queue all of these jobs up because it can take anywhere between 5 to 20 minutes to build that job in Unity. It's all scripted, it's all automated, but it can take some time depending on the size of the model. So this enables the lead to kind of go through and enter all of the jobs for the next day in rapid succession, and the system will just queue them up and just build them one by one, even overnight if needed. And then when they come in for the next shift, all the jobs are staged, ready to be retrieved by the HoloLens. So you can see the status of jobs in the queues. The left-hand side of jobs being built, and it shows which ones are complete. Right-hand side shows the screen of the user management, so users can be added and change the status, and every user is assigned a QR code. At the moment, that code is just it's called a BEMS ID. It's like an employee number. It's just encoded in the QR code. We're actually going to make that more secure. We're working with our InfoSec people to build out a more secure encrypted way of doing that. But every user has their code, and this is how they retrieve the content onto the HoloLens. More about that in just a second. So from the HoloLens perspective, this is what it looks like. When you put the device on, this was our own internally developed app. It's called Bark Wire Install. When you put the first thing on, it says you have to scan your code. That's how you identify the user or the electrician to the device. So you can either go up to the server, which is next to the airplane, and just look at the screen. You click on your name, and it'll show you a QR code, and you look at the screen. Or if you like, we find a lot of the people have actually printed their code out and stuck it onto the back of their badge. We all wear employee badges. And that way, they just hold their badge up and look at the QR code. That's kind of how they identify themselves or log on. And there we go. Oh, can you go back keep going back and again. Can you go back one more? Okay. So once they've scanned their QR code, it's going to download all of the jobs, like I said, are assigned to that electrician, and that's based on what was entered on the back end, what the shift lead entered, how we assign those jobs. So, I'm Paul. If I scan my QR code, I'm going to see 3 or 4 jobs show up here, and those are my jobs for the day. In this case, we've only got one. It's a demo. So you click on the job that you're going to work, and then it brings you to the bottom right-hand screen, which gives you some app controls, but also all the wires that are going to form part of your job. And this is where we have to kind of manage the view of the menu a little bit. So we built these little pin icons. You can kind of typical standard way of operating with HoloLens. You can look where you want a menu and pin it there. What we found was a lot of electricians are taking the wire list and pinning it next to their toolbox. So their toolbox sits inside the airplane. They'll just look at the list and they'll pin it there so they never have to look for it. They always know where it is. And they'll put the controls usually behind them so they never get in the way. That's it demonstrated here. Some of the functions that we can control on the right-hand side, we can turn alignment on and off, and I'm going to show you how the alignment works shortly. You can turn on and off like call-outs. So if you want to query the wire number for something, you can just look at it, and we'll query the model and display the wire number for that particular bundle. You can control all that through this menu here. The wire list actually allows them to select one wire at a time if they want to. So if they just want to see W0274, they can just click on it and it'll hide everything else and just show the route for that one wire. Or you can see all the wires for the job. Or if you want to see the whole drawing, you can see the whole entire airplane section, but that becomes really, really complex really quickly and hard to interpret. So usually they just look at one or a couple of wires. And you can, when they've installed the wire, they can click the little checkbox next to it and it'll just turn it green so they can kind of keep track of where they are in their throughout that job. Some of the functions on the right are things that are available through the voice command interface we have. I mentioned call-outs, bundle call-outs. You can move menus. You can highlight certain things all through your voice if you want to. So I talked a little bit about alignment. So we actually built our own kind of alignment process and system. We did some, maybe a year or two ago, I may have talked about this last year, we did some testing where if we're trying to figure out how to align this HoloLens content so that it's accurately placed in the aircraft to within about a half an inch, hopefully better. Half an inch is like our requirement. So we found that, if we're just using a single marker and tracking it with view forward or something, it's generally good to within, some local area. But as soon as you move, look a ways away, maybe 10, 15, 20 feet, that rotational error of tracking in the marker, that all of a sudden becomes significant, and you get the error shown on the bottom right, and all of a sudden your wires are an inch or two away from where they should be. So we actually put together our own process where we, instead of using the rotational tracking, we're just collecting 3 singular points in the aircraft, or anything else you want to align it to. And we 3D printed this handheld tool here, and we put basically a marker on the front of it, and then there's a little section in the handle where we can embed the HoloLens clicker and a clip that holds it on. And we use that to collect 3 points. We don't look at rotation, just the XYZ. On the back of it, there's a little point and a little tip, and you just touch that to 3 predefined points in the aircraft, and you press the little button, and then you look at on the menu, you say this is point 1, point 2, point 3. And what that does is it constructs a coordinate frame from those 3 points, and it basically rotates the HoloLens spatial map so that it aligns with the coordinate frame of the aircraft. So whenever we place something in the HoloLens, after we've done the alignment, it's going to physically align with the aircraft. And if you pick the points appropriately, you're picking them at a good distance apart surrounding your workspace, you can typically get down to, I've seen some alignments that you can't notice any error. Everything is just kind of spot on. Sometimes there's a little drift, but usually it's better than 1/4 of an inch across, size of a large commercial aircraft. So we're really happy with how that turned out. So this describes that process. You can see the tip on the back right there. And those 3 points are what I mentioned, the alignment points earlier. Those are the things that we're saying. So you can actually pick any 3 points in the aircraft you like. Usually we just pick something that is convenient to get to. And those are the set of alignment points that we have to select on the back end that you're going to use for that job. Let's see. Could someone at the back play the video for me, please? You should just be able to go forward one and just move the mouse, and there should be a little play button at the bottom. There you go. So this is a video demo. I'm getting close on time here. There we go. So this is the alignment process. So when you hold the tool up, it recognizes the marker. And the UI has been changed a little bit, but the concept is the same. That's one of the XYZ points that we've predefined. And then the button, you can't quite see it, but it's embedded in the handle. And the other one is shown there. And what we found was the electricians actually got really proficient at this really quickly. We were kind of concerned this was going to, add to, it's a little bit finicky and add to their workload, but actually, after a couple times of doing it, they can do this in like 10, 15 seconds. And so now the whole PI section, the whole production illustration, the whole model for that section is shown. Obviously, that's a lot of information, too much. I'm short on time, but in a few minutes, it's going to show them a list of their jobs, and they'll be able to choose one. And it's going to filter that drawing so that it just shows the 1 or 2 or 3 bundles that are part of that job, as I explained. So if you folks want to see the rest of this, I can show you offline, perhaps. I just want to cover 2 things really quickly. 2 ways we get value from this system. One is obviously the spatial registration. Everyone here is familiar with why that generates value. We don't have to look at drawings anymore. We don't have to interpret or commit to memory. We just have to do the job, and you see the data. But another big thing is the fact that we kit the data. We take a big complex drawing like what's shown on the left. Most of it they don't need for that job, and we filter it down just for what's needed for that 2 or 3 hour chunk of work, and then we put a bounding box around it, the blue box here. So it becomes very clear. It eliminates any time they have to spend figuring out what their job is. Lastly, I'll just mention that we did a time study using this tool. If I can get the slide to advance. There we go. We looked at 3 jobs. This is a sample of one of them. Had a bar time, which is a planned time of 90 minutes. Usually, they don't even meet the planned time for this particular aircraft, but the time is 90 minutes. And with the HoloLens, our system, they were able to complete it in just over 46. Even taking into account the 10-minute setup time it took to put the device on and do the alignment, we saw about a 40% productivity gain. And we've done some other studies that roughly align with that. With that, I'm sorry, I went over my time by a couple of minutes, but I hope you enjoyed the talk.